Welcome dear students, we are on the CEC Gurukul lecture. We are in the series of electronic circuits. Many equipments used or many electronic gadgets used in the development of the electronic circuit we have discussed. In the today's lecture we discuss the bridges, how we create electronic bridges and how many types of bridges are there in the electronic circuit. So today's lecture is based upon the electronic bridge. In this lecture we discuss what is the bridges and how many types of bridges are there, and on the basis of that we again just take the various bridges which is subdivided, and then what are the application of these bridges we will discuss in this series. Now what is the bridges? Electronic bridges. In the electrical components are arranged in a form of the bridge or the ring structure, then that electrical circuit is called a bridge. If we talk about the electronic bridge, we just arrange the electronic component in such a manner so that it form a bridge or a ring type structure, then it is called that type of circuit is called a bridge. And in general the bridge forms a loop with a set of 4 arms or branches. So when we connect the various loops in the form of the 4 arms and the branches, then we can say it is a bridge. Each branch may contain 1 or 2 electrical components. So what is the bridges? Bridges is the arrangement of the electronic components in the form of bridge or the ring structure. This bridge is in the form of the loop with a set of the 4 arms or the branches, and each branch may contain 1 or 2 electrical components. In this manner we form a bridge. Then types of bridge. We can classify the bridge circuits or the bridges into the following 2 categories, which is based on the voltage signal with which those can be operated. So bridges on the basis of the voltage signal can be divided into 2 forms. One is the DC bridge and second is the AC bridge. Now we will discuss these bridges in detail, and the types of these bridges again we can discuss further. So what is the DC bridge? DC, direct current bridges. DC bridge are used to measure the resistance of the circuit, while AC bridge are used to measure the impedance consisting capacitance and inductance. So DC bridge measure the resistance and AC bridges measure the impedance with the capacitance and the inductances. Apart from this, DC bridges use the DC voltage as the excitation voltage, and similarly here the AC bridges use the alternating voltage as the excitation voltage. So in this manner we can differentiate these 2 bridges also. So DC bridge gives the resistance, AC bridge gives the impedance, and DC bridge gives the voltage. The DC bridge uses the DC voltage as the excitation voltage, while the AC bridge uses the alternate voltage as the excitation voltage. You see on the screen there are the types of the AC bridge and DC bridge. They are again further subdivided. You see here that on the left hand side we have a DC bridge that determines the resistance, and further it is divided into subtypes like Wheatstone bridge and so on. And right hand side we have the AC bridge. On the basis of impedance, capacitance and the frequency it is subdivided. So these are the various form of the bridges. So we discuss first the AC bridge, and we will discuss the DC bridge and its type. So what is the AC bridge? AC bridge consists of the source, valence detector and the 4 arms. So if we just draw a bridge, then we use the source, electric source, then valence detectors, how we detect the balancing of this bridge, and the 4 arms. The arms of the bridge consist of the impedance. The AC bridge is constructed by replacing the battery with the AC source. It means when we talk about the AC bridge, then we use the AC source in the AC bridge. So the bridge are formed by replacing the DC battery with the AC source. then we can say it is a AC bridge. So the galvanometer with the Wheatstone bridge, as you all know, and you have worked in the laboratories regarding the Wheatstone bridge experiment. Then you see there we use the AC battery or AC source. So the bridge is used for detecting the impedance, capacitance, storage factor and dissipation factor we can measure by using this AC bridge. So we can say that AC bridge use the AC source just to get the deflection or to get the detection of the inductance, capacitance, source voltage and dissipation factor. Now you see this is the AC bridge. You see there are the 4 arms and connected with the source. You see on the bottom we have the AC source, and D is the detector which note the deflection in the bridge, and you see that it is connected with the resistance and the load. So R1, R2, R3, R4 and the loads are L1 and L2. Moreover, it is also having the current flow here. You see the direction of the current flow in this circuit. A and A, D, C are the A, B, C, D are the 4 points to just connect the bridge in the form of the loop. So this is the AC bridge circuit. Now the DC bridge circuit, DC is used for measuring the unknown electrical resistance. So this can be done by balancing the 2 legs of the bridge circuit. You see right hand side that here we use the DC power, electric power. E is their battery is used, and then here you see the flow of the current R1, R2. R1, R2 in place of R1, R2 we have P, Q, R, S resistance are attached here, and we balance this resistance, and you see B and D, in between B and D there is a deflection meter, that is a galvanometer that measures the deflection in the bridge. Again this bridge is connected with the A, B, C, D, and this can be done by balancing the 2 legs of the bridge circuit. Means balancing can be done by the 2 legs. The value of one of the arm is known while the other of them is unknown. You see that left hand side we know, but the right hand side means we don't know the Q and S value. Then by balancing the R and P we can find out the Q and S. So by balancing the value we can measure the unknown resistance of the circuit. So AC bridge, now we start the definition with the AC bridge are the circuit that are used for the measurement of the electrical quantities such as impedance, capacitance, resistance. Along with these, an AC bridge allows to measure the storage factor, loss factor, dissipation factor, etc. So if we talk about the uses of the AC bridge, then we can measure the storage factor, loss factor, dissipation factor by using this AC bridge. AC bridge operates with only the AC signal. The AC bridge is used to provide the phase shifting and providing a feedback path to the oscillator. Through this AC bridge, we can provide the feedback to the oscillator. There is also a phase shifting in this. But the AC bridge networking construction, if we see, you see here, then here an AC bridge consists of 4 nodes with the 4 arms. You are seeing here, there are 4 arms, like in between the I1 and I3 you see a source excitation that is on the bottom, and a balance detector that is in between that. You see the D is the detector, and source is on the bottom, and each 4 arms of the bridge consist of the impedance. So Z1, Z0, Z1, Z2, Z3 are the 4 impedance that are in the bridge. As we talk about the AC bridge, so we are measuring the impedance. So we use the impedance of the by using this AC bridge. Now the source and detector in the AC bridge network are connected in the opposite node. You see here the source and the detector are connected in the opposite node here, and this is so because if the source and the detector are connected to the same node, all the voltage and the current of the source will be displayed at the detector. but here we are balancing it so that we connect it in the opposite node. So in this condition the bridge will never come into the balance condition, because we are going to be balanced. So we connect the source and detector in the opposite node. If the source and detector are connected to the same node, then all the voltage current of the source will be displayed at the detector. So as we are getting the balance condition, so we connect the source and detector in the opposite node. Basically there are the two conditions in order to balance the bridge. What are these two conditions? First is the detector current ID should be 0. As we are balancing, so first we take the balancing in this circuit by making the detector current 0. So ID first in the case of balance will be 0. The second condition is the potential difference between the detector node should be 0. The potential difference between the detector node should be 0. Now the question arises that the balance or the null condition in the AC bridge, it is the condition when the certain specific applied circuit situation causes the detector current to become 0. It means we adjust the values of the impedance in such a manner so that the deflection in the detector current should be 0 and it balance it. So the certain specific applied circuit situation causes the detector current to become the 0. So AC bridge is a derivative of the Wheatstone bridge, and this is so because of its battery and the galvanometer of the Wheatstone bridge are replaced by the AC source and the detector respectively. Means we in the DC source, in the DC bridge, we use the battery as well as the galvanometer. But if we talk about the AC bridge, as we make the Wheatstone bridge as a AC bridge, then we replace the bridge with the AC source and the detector respectively. We replace the galvanometer and the battery with the detector and the AC source, and then we will make it the AC bridge, and it will behave as a AC bridge. And in case of the low frequency measurement in the AC bridge, the power line may be act as supply source, but in case of the high frequency measurement, electronic oscillators are used as the supply source in case of the AC bridge. If we measuring the low frequency, as we can measure the low frequency by using this AC bridge, then the power line may be act as a supply source. And if we talk about the high frequency, then electronic oscillator will supply as a source. So headphones, vibrations in galvanometer and the tunable amplifiers are the commonly used as a detector in the AC bridge. You have seen in the D-Sorty bridge that we sometimes use to headphones to check that the sound is coming or not. When the sound is coming, then it is balanced. So we use the headphones, vibration galvanometer and the tunable amplifier to get the detector in the AC bridges. AC bridge general balance equations we will discuss further. Then how we can balance the mm, balance the balance the circuit and what is the equation of that. Let us now move forward and derive the balance condition for the AC bridge. Now for the bridge to be balanced, this is the bridge, right hand side you see, this is the bridge and we have to balance this. So considering the above shown figure, as it is attached in this manner, you see here that basically that 4 impedance are connected with Z1, Z0, Z2, Z1, Z2, Z3, Z4 are connected. Moreover, current is flowing here, I1, I2, I3, I4, and the current through the detector must be 0. That requires the potential difference VBD is equal to 0. So first we balance it by through the detector we can get VBD is equal to 0. So in such condition, the voltage drop from A to B, you see on the screen, A to B will be drop A to B will get equal to the voltage drop from A to D. You see on the screen, A to B, then A to D. The voltage drop from both the side must be condition. This is a condition that the voltage drop from A to B will get equal to the voltage drop from A to D. Both the voltage drop should be equal, both in the magnitude and in the phase. So we can write the above stated equation as E1 is equal to E2. You see here, this is the E1 and E2. So we are balancing both the arms. So E1 is equal to E2. Applying the Ohm's law, we can write it as I1 Z1, because here we are having the impedance, so it will be I1 Z1 is equal to I2 Z2. At balance, we can get I1 is equal to I3. Then it will be E divided by Z1 plus Z2. Now I2 will be I4 is equal to E divided by Z2 plus Z4. In the similar manner, we can take on the right hand side, substituting the value of the I1 and I2, then we can get this equation, that is E by Z1 plus Z2 into Z is equal to E by Z2 plus Z4 is equal into Z2. Finally, this value we are substituting in this equation, I1 Z1 is equal to I2 Z2. Then we can get this equation after balancing it, after solving it, we can get Z1 divided by Z1 plus Z3 is equal to Z2 divided by Z2 plus Z4. Now we can take the Z1 this side and like cross multiplication we can do it, then it is Z1 into Z2 plus Z4 is equal to Z2 Z1 plus Z3. Now we multiply it, so we can get Z1 Z2 plus Z1 Z4 is equal to Z1 Z2 plus Z2 Z3, and hence after getting the result, the two terms will be cancelled, and the final result will be Z1 Z4 is equal to Z2 Z3. What is represent? This is the basic equation for the balancing of the AC bridge, and this equation is suitable to use while dealing with the bridge consisting of the series element. All the elements are connected in the series, so we use this basic equation of the balanced AC, that is the Z1 Z4 is equal to Z2 Z3. Now, on contrary, while dealing with the bridge consisting of the parallel element, that is in the series, right, but if it is in the parallel arrangement, then admittance of are used. So this equation will be y1 y2 is y1 y4 is equal to y2 y3. Here is z1 z4 is equal to z3 z2 z3. Here y1 y4 is equal to y2 y3. So theoretically we can say that the product of impedance of the one pair of the opposite arms must be equal to the product of the impedance of the another pair of opposite arms in the complex notation. So that's why we are taking y1 is equal to y4 and y2 is equal to y3. It means the product of impedance of the one pair of the opposite arms must equal to the product of the impedance of another pair of opposite arms in the complex notation. This means both the magnitude and the phase angle are to be considered here. So for this we take that, let us consider the impedance in its polar form. So we can write it as Z is equal to Z theta. Z represent the magnitude and theta represent the phase angle of the complex impedance. So above equation, that is this one, this equation Z1 Z4 is equal to Z2 Z3 can be written as Z1 theta 1 into Z4 theta 4, Z3 Z2 theta 2 and Z3 theta 3. So we can rearrange this equation in the case of the polar form. Now Z1 is equal to Z1 theta 1, Z2 theta 2, Z3 theta Z3 theta 3, Z4 is equal to Z4 theta 4. So here the impedance parameters will get multiplied with the angle will be added. So we can write it as Z1 Z4 theta 1 plus theta 4 is equal to, all the angles will be added in this. So Z3 Z2 Z3 is equal to theta 2 theta 3. Separately we can write the magnitude and the phase equation as Z1 Z4 is equal to Z2 Z3. If we write in the polar form, then we can write, if we take the magnitude as well as the angle, then we use the above equation, that is Z1 Z4 theta 1 plus theta 4 and is equal to Z2 Z3 theta 2 plus theta 3. And if we take only the magnitude, then it will be the Z1 Z4 is equal to Z2 Z3. The condition is above equation called the magnitude criteria. Then we can write it as theta 1 plus theta 4, then we can take the angle, that will be the phase criteria, right. If we take the Z1 and Z4 is equal to Z2 Z3, that will be the magnitude criteria. If we take the angle, theta 1 plus theta 4 is equal to theta 2 plus theta 3, then it will be the phase criteria. So in the bridge valence condition, magnitude and the phase criteria should be satisfied simultaneously. It means when we talk about the valence for the magnitude and phase criteria in a polar condition, then both must be satisfied simultaneously, like Z1 and Z4 with the theta 1 theta 4 is equal to Z2 Z3 with the theta 2 and theta 3. Now what are the application of the AC bridge? AC bridges are used to find the unknown impedance along with the associated parameters. Secondly, communication system and the complex electronic circuitry majorly makes use of the AC bridges. Another application is that it is used in the phase shifting and for filtration of the undesirable signal. When we want to remove some noise, then we use this AC bridge circuit. It is also used to measure the frequency of the audio signal. For the AC bridge circuits, two balance equations are always obtained. One is the magnitude and other is the phase equation. So we use it. If we talk about the DC bridges, then DC bridges are the two types. One is the Wheatstone bridge and the Kelvin bridge, and the various AC bridges are also there. There are the various AC bridges like capacitance comparison bridges, inductance comparison bridges, and Maxwell bridges, Hayes bridges, Anderson bridges, Carring bridges, and Wien bridges. So there are the various bridges there. In next lecture we will discuss another type of bridges. Thank you.